Hello everyone. Today, we'll examine one of the most insidious problems that developers face when implementing search in Flutter applications. I'll show you a real bug that can completely break the user experience and teach you how to properly avoid it using the BLoC pattern. If you've ever implemented search in your application and noticed strange behavior where search results don't match the entered query, this video is for you. Let's go. First, let me show you the problem with a real example. Imagine we have a regular application with search. A user wants to find information about Flutter and starts typing this word quickly. They type the letter F. Our application sends the first request to the server. Then they add the letter L, and a second request is sent. Then flu, a third request, and so on. It would seem logical. We send requests as they type and show results. But here's the catch. All 7 of these requests go asynchronously and independently of each other. And this is where it gets interesting. The request with the text Flutter, which was sent last, might return from the server first because the server processed it quickly. But the flu request, which was sent earlier, might take longer to process and return last of all. And what happens? The user typed Flutter. The application showed the correct results, but a second later the response to the old flu query arrived, and the interface updated with incorrect results. The user looks at the screen and thinks, I typed Flutter. Why am I seeing results for flu? This app is buggy. This problem in programming is called a race condition. Essentially, our asynchronous requests are racing each other, and we don't know who will reach the finish line first. Let's look at how beginner developers typically implement this functionality. I'll show you typical code that leads to this problem. For this example, I'll be simulating server requests in the repository. A search block is created. In the constructor, a handler for the search query changed event is registered. And here's what happens in this handler. First, a search loading state is emitted to show a loading indicator. Then, an asynchronous call to the repository is made to get search results. And after receiving the results, a search loaded state is emitted with these results. Looks logical and correct, right? But the problem is that we have absolutely no control over the order in which these asynchronous requests will return with results. We naively assume that the last sent request will return last. But that's not the case. Each search call executes independently, and if the first request takes longer to process for some reason, it can return after all the others and overwrite the correct results with incorrect ones. Okay, now let's solve this problem. The RxDart package comes to our rescue here. It allows us to manage events in the block. For example, with it, we can add what's called debounce. The idea is very simple. We don't send a request immediately after each keystroke. Instead, we wait until the user stops typing and only then send the request. Imagine this like a secretary who doesn't rush to execute your every word instantly, but waits until you finish the entire phrase and only then goes to carry out the task. How does this work technically? We add a special transformer parameter to the on method of our block. It takes a function with 2 parameters. Here we should return events, while calling its debounce time function, which takes a duration, the wait time. Usually, this is between 300 and 500 milliseconds. This operator does the following. It waits the specified time after each event. If a new event arrives during this time, the timer resets and starts counting again. And after this, we can use another useful feature. I'm talking about the switchMap method. SwitchMap monitors the event stream and performs a very important function. When a new event arrives, it automatically cancels the processing of the previous event. What happens from the user's perspective? The user types the letter F, a 500 millisecond timer starts. They type L, the timer resets and starts again. They type U, the timer resets again. They type T, T, E, R. Each time the timer resets. and only when the user stops and a full 500 milliseconds pass without new events, then a request is sent to the server. The result is amazing. Instead of 7 requests to the server, we send just 1. This saves server resources, user traffic, and hosting money. What does this give us? First advantage: debounce greatly reduces the number of requests to the server. If a user quickly types 7 letters, we'll send 1 request instead of 7. That's a 7-fold savings. Second advantage: switchMap completely eliminates race conditions. Even if for some reason 2 requests are sent in a row, only the last one will be processed. Third advantage: quick response for the user. 300 milliseconds is practically imperceptible to a human. It seems to the user that results appear instantly, but at the same time we're not spamming the server with requests. Fourth advantage: it works stably under any conditions. Slow internet, overloaded server, fast typing. In any situation, the user will get correct results. Try repeating this code yourself and add print statements for debugging in the events. You'll notice that even if you type many letters quickly, only 1 request will be executed, namely the last one. You can find the code from this video in the description below. There will be a link to a GitHub repository with a complete example application that you can run and study. If this video was useful to you, be sure to like it. It really helps the channel. Subscribe so you don't miss new videos about Flutter development. Click the bell to get notifications about new videos. Thank you so much for watching. Good luck with your development, and see you in the next videos. Bye-bye.